Hello friends, welcome back. Let us continue with the module of electrician trade. I am Rajiv. On behalf of Nimi, I will be guiding you through this exercise of testing single-phase energy meter for its errors. An energy meter is a very common device used in every household and commercial organization to calculate the amount of electricity consumed. But did you know that they may need an error correction for producing the correct reading? In this exercise, we will learn about it. On completion of this exercise, you will be able to identify the creeping error in a single-phase energy meter, test the energy meter for its starting current error, select the suitable loading arrangements for determining errors in a single-phase energy meter, determine the percentage error in an energy meter. Ensure the safety by wearing proper attire, goggles, gloves, and boots. The necessary tools required for this experiment are electrician's toolkit, single-phase energy meter, 5 ampere, 250 volt, voltmeter 0 to 300 volts, ammeter 0 to 5 ampere, power factor meter 240 volt, 5 ampere, ammeter 0 to 50 milliampere. The equipments required are single-phase capacitor motor with brake load 240 volts half kilowatt, lamp load single-phase 240 volts 1.25 kilowatts, single-phase auto transformer 0 to 270 volts 8 ampere. Other materials required are electric bulb 5 watt 240 volts with holder, 10 meter PVC insulated cable 1.5 square millimeter 1100 volt grade. Before getting into the practice area, let us know about some basics of electrical energy and energy meters. Energy meter is an electrical instrument to measure the amount of electrical energy used by a consumer. Electrical energy is the total power consumed by any electrical appliance for a period of time. Generally, electrical energy is measured in kilowatt hours. The electrical energy supplied by the electricity board is measured and billed based on the actual amount of energy consumed. The electricity board installs energy meters at the consumer's place, like in homes, industries, organizations, etc., to charge for the electricity consumed by loads. The energy meter has an aluminum disc that rotates, and the rotation determines the power consumption of the load. A light-weighted rotating aluminum disc is placed between the air gaps of two electromagnets on a vertical spindle. One magnet has a pressure coil and the other has a current coil. The pressure coil, having large number of turns of thin wire, is connected across the supply mains. The current coil, having less number of turns of thick wire, is connected in series with a load so that it carries the load current. The pressure coil produces the magnetic field proportional to the supply voltage, and the current coil produces magnetic field proportional to the load current. The interaction of the magnetic fields produced by the current coil and the potential coil produces a driving torque on the disc. Due to this driving torque, the disc starts rotating. The speed of the rotation of the disc is proportional to the current and voltage of the coil. A horseshoe-shaped permanent magnet is placed on one side of the disc. The permanent magnet exerts a braking torque on this disc. This braking torque opposes the movement of the disc, thus reducing its speed and bringing the disc to an idle state when load is disconnected. The cyclometer counts the rotation of the disc with the help of a gear system mounted on the spindle of the disc. Observe and note down the energy meter active condition when appliances are switched on and off. we can understand the energy meter working with different load conditions. Each observation should vary by a different number of appliances switched for the same time and its meter reading. Here we can notice that the number of rotations of the disk is proportional to the amount of power consumed by loads. We can simply say that when the load and loading time increases, the amount of energy consumption increases. Next, let us see what is creeping error in an energy meter. Creeping is the phenomenon in which aluminum disc rotates continuously when only the voltage is supplied to the pressure coil and no current flows through the current coil. Creeping is a kind of error when energy meter consumes a very small amount of energy even when no load is attached to the meter. The creeping increases the speed of the disk even under light load condition, thereby increasing the meter reading. Any vibration, stray magnetic field, and excessive voltage across the potential coil are also responsible for the creeping. Now, let us check the given energy meter if there is any creeping error in it. Connect the energy meter with a single phase AC supply through an auto transformer as shown in the circuit. Connect a voltmeter across the auto transformer. The load switch should be in off during the creeping error test. Vary the input voltage of the energy meter between 80% and 110% of the rated voltage of the energy meter through the auto transformer. Check if the energy meter disk is rotating without any appliance switched on. Since the disk is not rotating, we can say that there is no creeping error. Next, check the energy meter for its starting current error. The meter should start registering energy at 0.5% of its rated basic current at unity power factor. Now connect a 5-watt lamp to the energy meter and check the disk rotation. Since the meter disk starts rotating, we can say that there is no starting current error. Now let us conduct the test for percentage error in a single phase energy meter. Conduct the experiment at different loads in the circuit. Make the connections as per the circuit shown. Here we have connected loads of 1.25 kilowatt. At starting, keep all the lamp switches in open position. Observe and record the readings of energy meter with 25% of its full load. Repeat the experiment with 50%, 75% and 100% load respectively. Readings are to be recorded in the table. True energy is to be calculated as V into I into cos phi into T divided by 1000 into 3600, where T is the time in seconds, V is voltage and I is current in amperes and phi is 45 radians. For each load condition, keeping the load constant, count the number of revolutions of the energy meter disk for 2 minutes and record the count in the table. Energy registered by the energy meter should be calculated for each type of load in the experiments using the formula given. The lamp loads are considered as resistive loads. For inductive loads, connect the circuit with a single phase capacitor motor with 0.5 kilowatt brake load as in the figure. Adjust inductive loads by varying the brake load of the motor. Record the meter readings at 25%, 50%, 75% and 100%. Calculate the error using the formula error is equal to recorded energy minus true energy. Percentage error is equal to R minus A divided by A multiplied by 100, where R is energy registered and A is true energy. The percentage error should not exceed plus or minus 2% as per international standard. This concludes the exercise on testing of a single phase energy meter. I hope after watching this video, you are able to identify the creeping in energy meter, test the energy meter for its starting current error, select the suitable loading arrangements for determining errors in the energy meter, Determine the percentage error in an energy meter. Thank you for watching. See you all in the next exercise.